Yep, trig equations are back. Let's handle them. Let's go freaking handle this. Double angles now. And I'm taking them, ramping it right up. Trig equations aren't that bad with sine's double angle. Reason being, there's only one of them. Cosine's double angle. You gotta think. Now if we're tackling something like this, you don't want double angles. You see double angle, you're like, I know what to do. You're like, I'm gonna get rid of it. I'm gonna call it something else. I don't want the double angle. Because to solve this, we want a factor. We want to just get like cosines of x's and sines of x's and shit like that. Actually, for this one, since we have these options, we're like, but bro, but cosine of 2x, that's equal to cosine squared minus sine squared. It's also equal to 2 cosine squareds of x minus 1. It's equal to 1 minus 2 sine squareds of x. How the frick am I supposed to know which one to change it into? And they say, there's a cosine there. Which one just has cosines? Let's change it into that. 2 cosine squareds of x minus 1 minus cosine of x is equal to 0. So we just replace it out. But now everything's in terms of that same variable. You know how we've been treating a variable like that frickin' word cosine of x is a variable? Yeah. So we have 2 cosine squareds of x minus cosine of x minus 1 set equal to 0. I'm just going to jump aside. Just going to show you 2y squared minus y minus 1. I'm not going to do any weird freaking tricks. 2 is a prime number. 1 is just 1. This shit looks like this. And there's a 1 and a 1. You just have to figure out what sign it is. So there's no reason to do some big old freaking trick. We know this is going to work. Come on. So have you ever seen the smiley face trick? To just make one of them a minus and one of them a positive and just see what happens. So that's negative y. And that's positive 2y if you put it together. 2 smiley faces. Now what's negative y plus 2y? That's equal to positive y. Oh, shit, got the wrong one. Let's do the smiley face method the other way. Must have had it backwards. Let's go with a plus here and a minus there. So now you'd have a positive y in between that one, and you would have a negative 2y. When you put the positive y with a negative 2y, you get negative y. That must be the answer. Smiley face method just by guess and check. So there it is. We would actually end up with 2 cosines of x plus 1 times cosine of x minus 1 is equal to 0. Just from that factor, treating cosine as if it's y. We use the zero product principle. We set it equal to 0 and we solve. I will assume you got this on lock. So cosine of x is equal to negative 1/2. Cosine of x is equal to 1. On the right-hand side, we're only going to have one answer. When sine or cosine equals either 1 or negative 1, you're only going to get one value in between 0 and 2 pi such that it's equal to that value. Now, cosine of x is going to equal negative 1/2 at, well, I know the reference angle will be pi over 3. Also know that cosine is negative in the second quadrant and the third quadrant. So there are 3 answers, and oh boy. Cool. So double angles, you see them? Change them. If it's asking you to solve, get rid of them. Now this one. I looked through your homework. It gave you a couple tangents in there. And I'm not sure how they want you to solve it, but I solve these the same frickin' way every time. I don't pay attention to tangents double angle. I'm going to change this thing. And I haven't done this problem before, so this is going to be fun. So I'm going to call it sine of 2x over cosine of 2x. So I have no intuition as to where this is supposed to go. I'm just kind of doing this. Now, something's really frickin' bothering me. Do you see this too? And do you see this too? Do you mind if I factor it out to the front? Know what I mean? Hey, do you mind if I divide out that too? Thanks, guys. Thanks. It's just set equal to 0. Get rid of constants. This stuff's nonsense. All right, so there we are. Do you want to make common denominator? Let's make common denominator. Let's put this stuff together. So let's just do this. Let's go sine of x and sine of x. And notice I haven't even changed any of the double angles. And the reason why, I don't know what to do with the cosine of 2x yet. I'm confused. I don't see it. I don't see it. I don't know the trick yet. I'm not finding it yet. So that'll match, and then we'll do what cosine of 2x and cosine of 2x. All right. Now where are we gonna go with this? Like, this is a beast. This is a rough one. So we got that denominator to be sine of x cosine of 2x. That's that denominator. And now we have sine of x times the sine of 2x minus cosine of x times cosine of 2x. Oh, why my C got excited there. Cool, and it's set equal to 0. Do you know what never is going to make this thing equal 0? Ever. The denominator. So let's multiply both sides by it. So what happens? 0 times anything is 0, right? And when you multiply by the sine of x and cosine of the 2x, this just cancels. And it just leaves you with the numerator. Whoa, did I seriously write that? Did I seriously write that? Have you been screaming in your head going, what the hell did you put there? Sorry about that. Alright, and that's equal to 0. Now the games begin. The sine of 2x is not a big deal. We just change that thing up. So you get sine of x. Instead of writing in sine of x, we're going to write times 2 sine x cosine x. Now over here, I have no freaking clue what to turn this one into. I literally have no idea. So I'm just going to put it into the old standby. Cosine squared minus sine squared. Because I don't know. I don't know what it is. This is going to become something giant and nasty and terrible. I mean, like it hasn't already. So let's start putting things together and see if maybe there's something in common on all of these. Maybe there's something in common. Maybe things will cancel out. I don't know. So we're like, okay, well, let's start putting all this together and being like, well, that's 2 sine squareds of x times cosine of x. We're going to bring that into both pieces. So you get negative cosine of x cubed, and then plus cosine of x. Oh, let's write it this other way. You know what I mean? Let's write it this way. So sine squared of x, right? Because that negative cosine to that negative something. There it is. Cool. Do you see anything in common on? Ooh. Don't we have 2 of these sine squared cosines of x, and then we got another sine squared cosine x? So how many of those do we have now? Do we have 3 of them now? That's a cube. I saw it. Cool. That's a 3 if you didn't know. And now we're going to factor out the cosine. Cosine of x comes the other side, and we're going to be left with 3 sine squared of x minus cosine squared of x set equals 0. Do you know that we're finally there? We can now solve it and get some exact answers. Holy moly. Do you know this is one of your homework problems that I'm doing, yeah? I hope you know that. So now when we use our zero product principle, and there's other paths through this. Like I said, I didn't come into this with any intuition. I could be going the long way. There could be a much shorter, more efficient path that I missed. As I said, I didn't come in with any intuition. I just came in trying to solve it. So cosine is equal to 0 when your input is any odd multiple of pi over 2. And since we're only talking about 0 to 2 pi, we're just going to say, well, let's leave our answer with pi over 2 and a 3 pi over 2. Now the one on the right is a little bit more tricky, but it's not too bad. Now there's a few different ways that we could tackle this. You could change this into all into cosine squares if you wanted to and solve it in that manner. Or do you want to watch this little trick? Watch this trick. Here we go. Let's add the cosine squared over to the other side. Now let's divide by cosine squared. Okay, I'm not being very efficient here. That's 3 tangent squareds of x is equal to 1. Let's divide the 3 over. Now let's hit it with a square root on both sides. Don't forget your plus or your minus, and we're going to say that tangent of x is equal to plus or minus 1 over the square root of 3. That's a plus or a minus. That means we're going to take them all. That says we're going to go x is equal to, what's our reference angle? 1 over root 3, or root 3 over 3. Our reference angle for tangent will be pi over 6. And then we must have 5 pi over 6 where it's negative, 7 pi over 6 back where it's positive, and 11 pi over 6 for our final one of our answers. 6 freaking solutions. Holy crap. Yeah, that's a tough one. So I did the tougher of the two that you have with tangents double angle. I hope. This one has more answers. So I realized when looking through it was kind of a dick move on my part. But there's the path. Run it through. See you in the next one.